Hello, I'm Mr. Lineweber, and this is 4.5 Solving Rational Equations for Math 30-2. So the biggest difference with this lesson is that we're no longer working with expressions, we're working with equations. So expressions don't have the equal sign, equations do. We're going to have two types that you're going to see. One type will be a simple rational expression equal to another simple rational expression like this. And my recommendation for these types is just a simple cross multiplication. The other type that we're going to see is two fractions. You either have to add them or subtract them. So it could be plus or minus. Your two rational expressions, plus or minus, and then you're going to equal another rational expression. And the method of solving this one is the LCM method that I'm going to show you in this video. Just a quick reminder that if your equation has your rational expression just equal to an integer, then you can just put a 1 underneath, and then it'll be a rational expression. Alright, so like in the previous videos and lessons, the number one strategy is to factor the denominators. You don't have to worry about factoring the numerators at first. And then stating the non-permissible values is going to be really important because later on you're going to have to check your answer against those non-permissible values, and if your answer to your equation is also a non-permissible value, then we're going to have to reject it, and that's going to be called extraneous. And so when that comes up, I'll make sure to mention it. Alright, so the method is that we multiply each term by the LCD, eliminating all fractions. And when we cross multiply, this is happening as well. So this one method covers all of our bases. Now what's going to end up happening is when you simplify the remaining polynomial, there's two cases that you're going to be in. Case 1 is if it's linear, and case 2 is if it's quadratic. And so when solving linear, this is the type of equation solving where you have to get the x on one side and the number on the other, and then you can just divide by that coefficient to solve for the value. When it's a quadratic, you're going to end up in a situation where you have to make it equal to 0, the quadratic. And my recommendation is that you keep the lead coefficient on the squared term positive. That's my strategy. And then what you're going to have to do is you're going to have to factor it, if possible, and then analyze the roots of those factors. So those would be the solutions if that polynomial came out. And at the bottom of your formula sheet, you also have the quadratic formula, which will help you if you're working with quadratics, if you don't want to factor. So you can always use the quad formula if you don't want to factor. And then final step is make sure you check that solution against those non-permissibles like I mentioned. So when we look at these two examples here, we can see this one is that LCM strategy and this one is that cross multiply strategy, just based on the structure of the equation. So you can see on the cross multiply, it's just a simple ratio equal to a simple ratio, and then you're just going to cross multiply. Over here, you're going to have to find the lowest common multiple or lowest common denominator of all three of these denominators so that we can do a nice little algebraic trick. So I'll start with the cross multiply. It's a little bit easier. So remember that this binomial in the denominator has brackets around it. And so in fact I don't even jump into factoring when it's of this type. I just straight cross multiply like this. So we'll have a 3 outside of 5x minus 25, and we'll have a 10 outside of x minus 5 when we cross multiply. This is a nice little trick, and what we really are doing is multiplying by the LCM. It's just not obvious, and I wouldn't worry about that. I would just jump into this cross multiplication. Remember to distribute. And then this type of equation is what we call linear, because there's the highest power on any x is a 1. So this type of equation solving is the type that you've been most familiar with in your studies. So we want to get the x's on one side and the numbers on the other. I prefer to keep my x positive, so I'm going to subtract 10x on both sides, as opposed to subtracting 15x on both sides. Okay, so now we're going to have 5x minus 75 equals negative 50. And then the next step is to isolate the x alone. So add 75, add 75. This now gives us 5x is 25. And now we can divide the coefficient out. So we end up with 1x. So it looks like 1x is 5. Now you can see here that the non-permissible value is x cannot be 5, and if I was to factor out a 5 here, I would get the same non-permissible value, so that one doesn't add any non-permissibles. So this is our non-permissible. But right here we're saying that it's supposed to be equal to that. So this is a contradiction. You can't have both. And so if you end up in a situation like this where the only answer you get is also a non-permissible value, then what we have to say is no solution. So this rational equation has no value that satisfies for x. So when solving of this type, we have to use the LCD or LCM strategy. So I'll just jot it down here. You're going to need a 6 and an x as the monomial and an x plus 1. And then I just go right and start editing the question itself. So this will need a 6 as well as an x plus 1. This will need, so put it on the top and the bottom. This will need a 6x, put it on the top and bottom. This is going to need the x plus 1, x plus 1. Okay, so let's just clean up this left side of the equation. We're going to have 1 times 6 times x plus 1 minus 1 times 6x all over 6x x plus 1 equal to 1 times x plus 1 all over 6x x plus 1. And now when we look at this rational equation, we're going to make an algebraic maneuver here, which I'm going to call drop the denominator. And why we're going to do that is because if you think about this equal sign, well, take a look at the denominators. After we find the LCD for both denominators to be the same, they're already equal. So that's not going to help us any further if we keep it in the equation. Like, they're already equal. So what I can do is I can essentially multiply by 6x x plus 1 on both sides of the equation. And what that's going to do is it's going to cancel the denominator. And so moving forward, you don't even have to do that or think about that. All you have to do is just drop the denominator. So that's what I'm going to do here. Drop the denominator. And then you just work with the top. So you just have to now solve the numerator equation. So what that's going to involve is distribution, collection of like terms, and whether it's quadratic or linear, we're about to find out. So the 6 comes in. Got 6x plus 6 minus 6x equal to, now the x will distribute in, x squared plus x. Cleaning up the left-hand side, we have a 0 pair. 6x minus 6x is 0. So we have 6 equal to x squared plus x. I can't make any further simplifications, so this is a quadratic. And so to solve quadratics, we put 0 on one side and the rest of the equation on the other. So I had to subtract 6 on both sides to do that. And notice how I keep the lead coefficient positive. This positive 1x right there. I want to keep that positive. So now I can factor this. I'm looking for two special numbers that will multiply to negative 6 and add up to positive 1. So two special numbers that multiply to this, and then two special numbers that add to positive 1. So it's definitely going to be xx in those front terms, because x times x will give us this x squared. Now we got to think about the two numbers. What's going to multiply to 6? So 2 and 3 or 1 and 6. These are our only choices. And then we can see that these will have the separation of 1 that we want. So it's going to be to make a negative, it's going to be positive 3 and negative 2, such that when you add those, you get positive 1. Alright, and I've reviewed that factoring strategy in lesson 0. Now the solutions to these are negative 3 and positive 2. Those are the solutions. Those are the actual x values that satisfy the equation equal to 0. Now when I go up and scan against my non-permissible values, I see that x can't be 0 and x can't be negative 1. So these are my non-permissible values, and none of them are the same as my actual answers. So these are the two solutions to this rational equation. All right. So as we continue on, staring at these denominators and looking at the overall structure, this is the LCM method. Same with this one, and same with this one. So I think I'll just do one more for this video. I don't want to make the video too long. You can check my website for the rest of the solutions. So in the first, because this denominator has this like x squared business, I don't want that in there. I'm going to have to factor out an x. Alright, so you can see here that the monomial for the LCD is just going to include an x. There's no numbers involved. And the only other binomial is x minus 3. So I just got to make sure that each denominator has that LCD. So starting from the right, I'll need an x minus 3, top and bottom. I'll need an x and an x, and that one's good to go. Now I can drop the base and solve the top. So I'll have 6x minus 5 outside of an x minus 3. And keep in mind that when you're subtracting, so you got a minus 5, that's going to have to distribute through. This is that negative trick in action. So remember to distribute this negative 5, and you notice the most important piece is that this sign will switch. Simplifying, 6x minus 5x is 1x. Subtract 15 on both sides, and you see that x is 3. Going up and cross-referencing against my non-permissible values, I see that x is not allowed to be 0 and not allowed to be 3. So once again, we end up in a situation where we have no solution because of the non-permissible value and this solution are contradicting themselves. And I think maybe just I'll just do the last question here, and then I'll show you the quadratic formula so that you actually have it, you've seen it once. So taking a look at this, we have an integer there. So what I'm going to do is put a 1 underneath it. That will help you understand what's going on there. And so taking a look at the LCD method, because I got the addition on the left, so I'll need a x and an x minus 4, it looks like. So let's start attaching those with multiplication. So I'll need an x here, an x here. I'll need both on this term. And over here I'll just need the x minus 4. Alright, so taking a look at the left hand side, I'll have a 10 outside of an x minus 4 plus a 3x outside of an x minus 4 equal to an x outside of an x plus 9. And I have the LCD in common on both sides, so I can just drop the LCD. I don't need to think about it anymore. Distributing and collecting like terms. Got 10x minus 40 plus 3x squared minus 12x equals x squared plus 9x. And so after simplification and collecting of like terms, I can subtract x squared on both sides. So I'm going to have 2x squared. So this one looks like it's coming out linear. I'll put these two together, 10x and negative 12x for negative 2x. And I got that minus 40 still there, and I got that 9x still there. Alright, and then I just need to bring this 9x over. So I'm going to subtract 9x on both sides. Alright, and now you can see that we have a quadratic where the coefficient here is not 1. And so that simple factoring of looking for those two special numbers is not going to work here. We have to actually use decomposition, which I'm not going to worry about. I'm just going to use the quadratic formula. So negative b plus and minus b squared minus 4ac all over 2a. This will actually solve for our x values. And so looking at my equation, a is 2, b is negative 11, and c is negative 40. And so plugging in, I'll have negative 11 plus minus b squared minus 4ac is going to be negative 11 squared. Make sure you put that in a bracket in your calculator or else you'll have major issues. Minus 4, a is 2, c is negative 40, all over 2 times 2. Negative 11 is positive 11, plus and minus. Now I'm going to grab my calculator. We'll have 11 squared is 121. And then a negative 4 times 2, or I'll just leave the minus sign, and I'll just multiply 4 times 2 times minus 40. So positive 4 times positive 2 times minus 40 is negative 320 all over 4. So 11 plus and minus the square root of 121. Negative negative means plus, so 121 plus 320 is 441 all over 4. Now the square root of 441 is perfect. So we end up with 11 plus and minus 21 all divided by 4. Okay, and remember that this is going to satisfy our x values. So now I can expand this for you. So let's do the plus first. 11 plus 21 over 4, and then I'll do 11 minus 21 over 4. Okay, and the two answers are going to be 32 over 4. So one of the answers is x equals 8. Now 11 minus 21 is negative 10 divided by 4. And negative 10 divided by 4 is negative 2.5. And so this is the other x value. So these two values are the solution, as long as I just double check the non-permissible values. So it looks like the non-permissible values, x can't be 0 and 4, so both of those are okay. So this will be the end of the video for lesson 5A. I'm going to do the word problems and the context-based problems in another video that's going to be lesson 5B. Good luck, everyone.